slide, Jason. So last housekeeping item. We are going to do a Q&A using the function. If you see that onto the right side of your screen, we'll be asking you to put any questions that you have for speakers. Please put their name of who you'd like it to address it to and your question. And Maya, Jason, and myself will kind of share those out to the speakers as we get to the end of our program today. And we'll be keeping kind of a running list of those on our end. But please don't use the chat function. The Q&A is where we'll be taking questions and answers, and we'll do that at the end of both speaker presentations. And with that, Peter, I'm going to turn it over to you.
Okay, good morning, everybody. Thanks for listening in. I hope you get something out of this presentation. What I'm going to do this morning is talk about my process of developing a concept from initial design idea all the way through to fabrication and installation. And then Roger and Denise are going to take over from there, and their focus is primarily on installation. So that theirs will be very interesting for you too. Jason, go to the next slide, please. So my process is quite different from most artists. Go ahead, Jason. I don't have an assistant in the studio. I don't have a rep. I don't have an agent, and I fabricate all of my own work. So that's not the typical way. Next, please. That's not the typical way that this is done. Most artists who do public projects work with a lot of other people, and other people do the fabrication for them. But I manage all of the aspects of a project from the very beginning to the very end. I do work with other people. I have a CAD designer that translates my drawings into CAD models. I, of course, have to work with a structural engineer to make sure that these things don't fall down or hurt somebody. And I have parts cut using water jet and laser machines, and I have some parts machined occasionally. I use powder coaters, and I have a small crew that helps me with my installations. Next, please. But I, of course, collaborate with arts administrators like the folks that are hosting this meeting today, architects, landscape architects, building contractors, crane operators. But it's my responsibility to bring all these things together, and I'm responsible for every aspect. Next, please. So my projects start with a simple sketch or two, and what I'm going to do is focus on one project just so you can see the development of it from beginning to end. And this is a project that I made in 2015, I believe, 13. This is at the Pierce County Skills Center in Puyallup on a campus of a school that's an adjunct to the Bethel School District, where high school kids can take, that's okay, go ahead. High school kids can take classes outside of their normal school day in all kinds of subjects, including firefighting and construction and nursing and veterinary medicine. These are skills-based curriculum, so that these kids can get some really useful training that they can find a career in. So initially I start with an idea and a couple of really crude sketches that give some sense of the scale of the piece, the general arrangement of the components, how big it is, what's it made of, what kinds of finishes does it have on it. Next, please. And then I cut and paste and put the sketches into the site to try to get a sense of, again, of the scale, but also of how it relates to the site and how things fit together. Next, please. Once that initial design has been approved through those sketches and presentation, then I go about the process of developing it further and really fine tuning it. And I usually, go ahead, please. I usually build a scale model of each of these projects. It does a couple of different things. One is it makes it easier to present the idea to a selection committee where they can see something three-dimensionally. It's much easier to explain than looking at drawings. And they can see it from all sides, and they can get a better sense of the scale of it. And the other reason it's useful for me is that in the process of building the model, I start to think about the process of actually building this thing full scale. So I work out in my head how does this actually work? How are these things connected to the ground? How do the parts connect to each other? How is it going to be finished? All those kinds of things. And the process of building the model triggers that thought process and gets me going on figuring it all out before I actually start to build it. Next, please. So the drawings and the model are then translated into a 3D CAD model. And I have a really wonderful guy that I've been working with for many years on projects, and he's an expert at CAD design, and he's always told me he could teach me how to do it, but I know that the learning curve is so steep that it's worth it to me to pay him to do it. I could never be as proficient at it as he is. So that's something to keep in mind. If you have the skills, that's wonderful. But if you don't have this, all the skills you need, there are people out in the world that can help you with those things. And so my guy, Patrick, does these CAD models for me. So he'll take my three-dimensional model and my sketches and start translating those into something that is really detailed, precise, and accurate in terms of dimensions and component parts. Next slide, please. So here's an example of one of the CAD drawings that shows every piece of this 15-foot tall hammer. And each piece is numbered, and there's a separate drawing for each part that shows its exact dimensions and configuration, what material it is. And these patterns then these digital patterns get emailed off to the water jet cutter, who programs them into a machine that cuts all these parts out. So back in the old days, I used to make everything by hand. I hand cut every single piece, which you can imagine is extremely time consuming and labor intensive. And I've found that it's much more efficient and ultimately less expensive for me to hire somebody in industry to make those parts for me. And then I literally go and pick up a pallet full of component parts, and it's a kit then, and I start putting it together. So you can see how complex even such a simple shape as this hammer, you can see how complex it is and how many parts there are and how it goes together. So next slide, please. So next, please. So then the process starts of fabrication. So I've picked up this kit of parts and I'm working in my studio to assemble them all. This particular piece is made out of aluminum. And in fact, the vast majority of the pieces I build these days are aluminum for a couple of reasons. One is that it's much lighter weight than steel. Aluminum weighs a third as much as steel. It's also much more corrosion resistant. And it's easier to cut and manipulate. So I can use a lot of basic woodworking tools even on aluminum, whereas I have to use a cutting torch, plasma cutter, things like that for steel. And the other real advantage that I think is a kind of the most important is that it's so much more corrosion resistant. So these things ultimately get a powder coated finish. Next slide, please. But if that powder coated finish gets damaged, if it gets scratched and exposes bare metal, the aluminum isn't going to bleed brown rust out of that scratch, but a steel piece would, and that rust stain will coat the surface of the piece and bleed down onto the footing or the plaza or wherever the piece happens to be sitting and leave a really unsightly stain. So this using aluminum eliminates that. So you can see now there's a lot of different parts to this, and there's a structure to it. The majority of these pieces, all the skin of this, we're looking at the one end of the hammer handle. The skin is made out of 3/16 aluminum plate, and these structural ribs are also 3/16. Next slide, please. Some of the pieces have to be shaped, so I do an annealing process, which is heating them up to a specific temperature range and then letting them air cool, and that makes the material very malleable. So this is heating it with a torch, and you can see the flame there, but I think this is probably a part of the claw of the hammer, a piece that ultimately gets curved. Next slide, please. And then, of course, all the parts are welded together. You can see now we're looking at the hammerhead, and you see that elliptical shape in the center. That's actually a hole that when it's finished, and you'll see this in a couple of slides down the road here, there's an access panel that gets attached there. That gives me access to the inside of the hammerhead, which is where I make the attachments, the head to the handle and the hammer to the foundation itself. Next slide, please. Now we're looking at the hammerhead where it attaches to the handle. So in the install, I'll be reaching up through that access hole that we just looked at and putting bolts through these holes. There's also a hole through the center, which you can see there, and there's a stainless steel column that gets mounted to the foundation, and all these parts slide down over that. So there's a structural post in the center of it. Next slide, please. And there's the piece finished in the studio, finished to the extent that it will be in the studio, and then it goes off to the powder coating company, and they sandblast it and put an epoxy primer coat on it, and then the final color coat. Next slide, please. Okay, these are the nail benches that sit around the bottom of the hammer, and you'll see this better in an installation shot. Go ahead, next slide, please. This one is my favorite. The concept of this piece is that a hammer is the most basic of all tools, and it sort of by extension represents all of the tools that might be used at this school to learn a different skill. So, and the concept of the nails is that it takes some practice to learn how to drive a nail without bending it over. And the idea being that failure is part of learning how to do something, and that's okay. Failure is an acceptable step in the learning process. Next slide, please. Oh, let's go back for 1 second just on an interesting fabrication note. I don't know if you can really see this very well, but in the curve of the nail itself, you can see some, looks like wrinkles there. And this is really interesting. When there's a shop that does pipe bending for me, and I had drawn this thing out and built a scale model, and I knew exactly what radius I wanted that bend to be. And I took the material to them, and they bent it, and they called me up and they said, you need to come down and take a look at this, because it really didn't work the way we intended for it to work. It got all kinked when they bent it. And I said, well, I wasn't really expecting that, but maybe I can use it anyway. And the more I thought about it, the more I liked it. And it actually makes it look more like a real nail. And the best part was they said, we're not even going to charge you for that because we screwed it up. And I said, well, you may have screwed it up, but it's better than I even imagined it would be. Okay, next slide, please. So you can go to the next slide. So the installation part of it requires some extra hands and some other equipment that I have to hire in. And you'll see a lot more of this kind of stuff with Roger and Denise's presentation. But you can see in this slide, the crane is set up right next to where the sculpture's being installed. And we've already installed the hammerhead, and it's been anchored to the foundation, and that post that's running up through the center has been anchored. And now we're taking the hammer handle and lowering it down over that post, and then I'll be bolting the two components together. You can also see the posts for the nail benches are put in place there. There's a part of this project that isn't visible that's really key to making the installation work, and that is the concrete footings. It's sitting on a concrete plaza, and I want it to look like it just got set there. It just appeared there. I didn't want to have a big concrete footing visible that's new concrete around each of the pieces. So in the process of working with the structural engineer to design the footings, I told him that what I really wanted was for the footings to be, they could be as deep as they need to be, but I want the footprint of the footing to only be as big as the piece that's sitting on top of it, so that you don't see the footing at all. So the footing for that hammerhead is only as big as the footprint of the hammer that touches the ground, and then it goes down about 4 feet into the ground. So we had to, with a concrete saw, cut the existing slab, excavate all the way down, and then create this very deep footing for that tall hammer. And the benches, the nail benches, also have a very deep footing that's only 4 inches in diameter, because that's the diameter of the pipe that sits on top. So the idea was that you would have no visible extra new concrete around the site. Okay, next slide, please. So here you can see I've got that access panel off, and I'm reaching up inside and attaching the hammer handle to the hammer head. And you can see now we've put the tops on those benches too. An interesting thing to note on this particular project too is this wood grain finish that you see on the hammer handle. To my knowledge, it's the first public art project that ever had that. Had never seen it before. And this is one of the benefits of having long-term relationships with outside vendors and industry. The powder coating company that I work with, I've been working with for 25 years at least, probably, and they came across this process of putting patterns on material and powder coating. It's a powder coat finish that looks like wood, and they could do all sorts of different wood grains. They could do different patterns, even animal prints or flowers or whatever graphic image you could come up with, they could do. So I thought this was perfect. I actually was just about to have them powder coat this handle, and it would have been a solid color like the model was, but they had just started doing this process, and I said, well, let's give it a try on this one, because it would really make this piece something special. So it's a very interesting finish. You can't scratch it, you can't peel it off. It is permanently bonded to the surface of the metal. It is a powder coated finish, and it's as tough and durable as any other powder coated finish. Okay, next slide, please. So here, well, you can see the wood grain maybe a little bit better there. So here I'm putting the screws into this access panel to close it off. To me, even the access panel is part of the design. It would be very easy to just put a square hatch cover in there. But I thought, well, that's not very attractive. It's not very elegant. So I think it's important to come up with the most elegant solution to every issue. So this ellipse almost looks like it's a logo or a stamp on the side of the hammerhead. And I'm also using tamper resistant screws that they're a Torx drive screw with a pin in the center. So you have to have a special tool to remove them. And that means it's very difficult for somebody to get inside there. Okay, let's see. Go to the next slide, please. And once we've got everything installed and buttoned up, then you have to go and clean it all up, make sure you get all the fingerprints off and any mud or boot prints that happen to be laying around. You clean all that stuff up. Next slide, please. And then I photograph it. And this is something I highly recommend you consider when you're doing projects, especially out in public places. You document them immediately, because the piece is never going to look as good as it does on that day. Even if the weather isn't ideal, as soon as you turn that piece loose to the public, then there's a potential for something to happen to it. And it might not be anything malicious. It might be just, some footprints on the plaza, or some smudges on the finish, or, handprints or something like that. So I always make sure I clean it and photograph it right away. And sometimes I'll go back later and photograph it again, but I make sure I get good documentation on that very day. Next slide, please. Okay, next slide. So it's very satisfying to finish a project. I get a huge relief after months and months of thinking about it and fretting over it and stressing about every detail and worrying about getting the installation done without anything happening. Nobody gets hurt, nothing gets damaged. And part of the reason that works is I have this really great crew. And you can see we're all getting a little gray, but these guys have been helping me on projects for years. And I do the fabrication by myself in my studio, but these guys always come out to help me on installation day. And we always have a good time working together. Okay, next slide, please. So next slide. So then it's finally finished, and it's open to the public. So in this particular case, it's a public piece, but it's on a school campus, which has limited access to the general public. But the students who use the facility have easy access to it, and it's meant to draw people in. You can see this thing from anywhere on the campus, and it draws you in and creates a little gathering space. And that image shows that wood grain pretty nicely too. Yeah, next slide, please. Next. You can, in that slide, you can see the wrinkles in that pipe that I was talking about. The benches, by the way, are made out of stainless steel. And so the hammer is entirely made out of aluminum and it's powder coated, but I didn't want to have any kind of finish at all on the nail benches, because I knew that those would be actually touched a lot more, climbed on and stepped on, and probably skateboarded on at some point. But so they're made out of stainless steel with no finish at all. And the advantage of that is that that surface that's there is infinitely restorable. I can always go back. If it gets scratched or gouged, I can always go back and sand it out. And it doesn't require any kind of coating on it. Okay, next slide. And the very last thing is to create an identifying plaque. And this happens with every project. This particular one is a Washington State Arts Commission project, but I've done projects for the city of Seattle and King County and lots of other lots of other municipalities and venues in various parts of the United States. But almost every single one will have a plaque, something like this, that identifies the artist with the title and the date, what the thing is made of, who the commissioning agency is, and a very short narrative description of the project. So that's how it goes. You do a few initial sketches and you end up with a finished project. It takes a lot of time, a lot of patience, a lot of coordination with other people, but I think that I happen to have a pretty good skill set that has allowed me to do this kind of work for a long time, and I still enjoy doing it, and I hope I'll be making lots more. So that concludes my talk. I'm going to pass it on to Roger and Denise.
Yeah, we're going to pass it on to Roger and Denise, and then we'll take questions for Peter and Roger and Denise at the very end. Thanks so much, Peter.
Thank you.
Hi. First, I want to say, Peter, that was an excellent presentation, and what a super fun piece of artwork. We'll definitely go out of our way to go see that. So that was a great presentation. Very comprehensive. So thank you. Thanks. Just briefly, Roger and I started our company in 2014 after about 15 years of previous art handling installation experience. We set out to support, primarily to support public artists through installation, consultation, and whatever else is needed to support. What the purpose of our presentation today is to kind of show you how we work through developing an installation budget, and all of the principles that we point out can be applied to whether or not you hire someone to do the installation. These are the questions that we would ask you, or if you're going to walk through the process yourself and put your entire project together like Peter did. So we're going to touch on how to avoid some common mistakes when you are putting together that budget, so that ultimately our goal is always to make sure that the artist in the end puts money in their pocket, is the bottom line. Next slide, please. Some of the common mistakes that we do see is that artists will assume a certain percentage of the total art budget for installation without considering the aspects that go into installation, and this can be a costly mistake in the long run. Next slide, please. So how and when does one develop an installation budget? So some common questions just to kind of kick it off is, these are the questions that you would ask yourself. Do I need engineering? What will the job site look like at the time of install? How will my art get from the shop to the job site? What equipment is involved? Am I qualified to do the install? Do I have the right certificates and training? There are a lot of factors that determine an installation budget. Next slide, please. Can you go back one, please? Sorry, okay, next slide, please. Okay, I think we jumped there for a bit. So the process of public art installation is not a creative process. Install is laden with, often install projects are on construction sites. So install is laden with rules, regulations, risk mitigation, construction industry standards, and all under the scrutiny of stakeholders and the public. The job site will determine the level of complexity, which can make a simple install very complicated. And more, what we're seeing in the state of Washington is that it's becoming a requirement of the installer that you or a professional installer be a licensed general contractor for the reason and purpose of liability. Next slide. This is an install that we did earlier this summer for the city of Seattle. And while this looks like a very simple install, and it generally was a simple install, it is on an active construction site. It's the early phase of the construction site, but we were still subject to all of the OSHA rules and regulations that would be applicable for a very active construction site as well.
Yeah, it's exactly like Denise just said. A lot of your projects are going to be at the tail end of a construction project if they're in that type of situation. However, this was at the front end of the construction of this site, so it's pretty much bare ground. It's pretty easy. The work is being done off a ladder and so on. But we were expected to recognize and maintain all of OSHA's requirements. So as simple as this is, it's screws and lap and fabric mural and a couple ladders. But as simple as this, the construction general contractor, the construction superintendent were there on site to make sure that everybody had the proper gear. So that would have been boots, gloves, eye protection, and that we were hard hats, and that we were using the ladder in a safe manner. And they were actually there and watched us do it for only maybe an hour. So they needed that confirmation that should OSHA drive by or a neighbor complain, that we were compliant. So as simple as that job was, and you folks are going to be in the public eye because you're working to produce public art, you do have to be cognizant that there are other people watching with official agendas. So you do need to look at what your parameters are on those install sites for sure.
Next slide, please. So planning and budgeting. So budget for install should occur in tandem to developing your final shop drawings, engineering, and project logistics. So in other words, for installation, when developing your budget, you want to start that in the very beginning of the process and not at the end. Next slide, please. A licensed general contractor with a focus on public art, we break down every project in the same manner and in two general parts. We look at the artwork. We evaluate the weight, the size, and the type of material. You'll tell us, but is it to be assembled and how? Is it to be anchored and how? Has the art been or need to be engineered for structural stability? How will it be transported to the job site? And then we break down the install site and the client requirements, because each client will have potentially, might be one person, but there's often a team involved, and they each have their own requirements. So we look at, again, within that parameter of the install site and the client requirements, we focus on the method and process of anchoring and the associated equipment and tools, what those job site restrictions and other vendors on site will be, what the public and job site safety requirements are, and then the contracting and the liability insurance. So there's quite a bit that goes into putting together your budget. And while we might not always have, or you might not always have the answers to these questions up front and in the beginning, they're what you need to kind of keep in mind all along. And then they all eventually do come into a focus. So kind of strategizing and looking at it holistically from the beginning is a smart way to look at it. It's how we do it, and it's what we recommend. Next slide. So we merge those two components together. The process of determining an install budget merges all aspects of the art and the job site together. There are three basic areas of focus to get to that budget, and we're going to break down each one of these. But it starts with as-built and shop drawings for engineering, those job site restrictions, and then what kind of equipment needs will be involved. So this is actually a project that we show in a later slide as well. And the challenge here was that, literally in this particular slide, was how do we get this heavy crate to the job site? We did not have a loading dock and a clear path. So we'll touch on that in a bit.
One thing that we haven't mentioned here is you may require shop drawings for the fabrication of your piece, especially if you're going to have somebody else doing it. So Peter did an excellent job of creating shop drawings using CAD so that he could get the pieces cut, and then, like you said, numbered so that he could actually fabricate them. So he had a kit. Developing those shop drawings, an artist can often think that, or may think that they can produce a shop drawing. But doing a technical shop drawing for a fabricator is really difficult. We've been doing them in a small manner scale for quite a few years, and every fabricator seems to expect a little bit different approach to the drawing, what they want to get from the drawing. Long story short is this is another thing that you need to budget into your time, if not your contracts, because they do take a lot of time. It takes a lot of discussion with the installers, the engineer, and the fabricator to produce an effective shop drawing. So that's another mental aspect of your job that you need to think about early on.
Yeah, and as you grow and develop as a public artist, your projects may get more and more complicated, and there are actually companies out there that will do those shop drawings for you, because it is literally the starting point for your once you get into large scale public work, and even as a good practice for even the smaller ones. It's a way to, like as Peter had pointed out too, it's a way to start the thinking process of how will you make this piece ultimately. Next slide. We're going to break this slide down a little bit. So this is a project that we did in Oregon, at the University of Oregon. This is where we look at, we basically break down the attachment method, the art assembly, and the job site conditions all merge for a complex install. So in the case below, the drop ceiling was already installed, but the anchors needed to be installed inside of that ceiling. And then we had challenges with the art as well. In this case, we needed to assemble the artwork, and we needed to assemble it once we were on an elevated platform. And all of the cables had to be plumb, so perpendicular, perfectly perpendicular from the ceiling down to the artwork. And each one of those pieces had 3 cables. So how do these things come together on the job site? And just as an added challenge on this job site, the artist was based in Texas. We were based obviously here in Seattle, and the job was in Oregon. So a lot of this was done without a site visit. So there were a fair amount of challenges involved. A lot of pre-planning went into this install.
I think the artists were actually in Michigan?
Texas, I think.
Okay.
Metal up.
Well, we had, okay, you're going to call them the artists. Okay. So, what they had done in order to meet their contract is the GC went ahead and installed this drop ceiling. It's a finished wooden lattice type of ceiling, leaving panels, access panels for us to, knowing that art was going to be going in there, leaving access panels available for us. But because it was in Corvallis and the art was coming out of Texas, we had no opportunity to get to Corvallis in time to see what was up in that ceiling. So the drawing that they gave us, all we knew is the parameters of the ceiling. But what they could give us was, this is not necessarily an as-built. It's not certainly an engineering or architectural drawing, but it is an image that they put together depicting as best they could remember what we would see when we dropped that ceiling. There weren't as-built available. There was only the original architecture and engineering available. They commented to us that they could not guarantee that some of this HVA system and mechanicals that was buried in that ceiling would be in the exact locations that we could see from either the architecture or even this. This is just it's kind of a pretty a pretty to look at digital cocktail napkin type of drawing that we were expected to use. So we had to come up with a couple different hanging systems in anticipation of dropping this ceiling and finding one condition or another. So what we're trying to get at here is that there was a whole lot of technical conversation going on between us as the artist rep and the general contractor on site. Now, the people that had put in this HVAC system were long gone from the site. This building was ready to open up in a couple of weeks, so we weren't able to directly communicate with those people. So our dialogue was strictly between the artists and this drawing that we had and what we would find when we opened up that ceiling. So it was, fortunately, we were prepared for it. We were down in Corvallis. There's not a lot of vendors and suppliers down there. We basically took half our shop down there. We were working about 32 to 36 feet up in the air. So we could only take just so much up with us at any one time. And we worked through it, and it was, we got it done. And everybody was happy with it. But the fact remains is you have to plan on, if you get into some kind of a complicated install like this, you have to plan on a whole lot of dialogue and you know, spending time talking to people in an effective and maybe even technical manner.
One of the things you might be thinking is that's a super complicated install and a super complicated art project and probably had a really big budget, and I'm so far away from that. And the reality is that you may not be that far away from this kind of an install. You know, right now we are working with an artist who is quite a successful artist here in Seattle, but she's doing her very first large scale project, and it has kind of quite a few of these same elements that will come together. And you know, it's her first big major one, so it's you know, it's something to kind of keep in mind. Next slide. This is again another complicated project, but the same basic elements will apply for in general. So this project included something that we're not going to go into very much in this presentation, but it included an oversized transport of multiple components, multiple types of equipment for both lifting the components and then another piece of equipment for assembling them. And it was in a very high visibility setting in a brand new parking lot. So there was quite a bit to think through on this one. We talk about this project a little bit more. This was just to kind of give you some background on it. This is for the city of Seattle, down in the International District. We were a subcontractor to the artist team. So there was quite a bit of collaboration between us and them so that they could liaison with the city on what was needed for this install. And one of the things for this one that is something to kind of keep in mind for pretty much for any public install is the job site of making sure that you know, a pristine job site like a brand new park, that once you're done with your install, it looks like that brand new park. So all of the ground protection you can kind of see in this slide here.
Yeah, in regards to that, so the actual entrance to that job site is off to the left of the screen, maybe 60 some feet from the entrance to where that little carry deck crane is parked. So like Denise said, this was a brand new park, brand new concrete surface. And so we were required to protect that surface. In order to get that crane on there, you can see that it's sitting on plywood. Those are inch thick pieces of plywood. So here's and this goes for actually if you're installing, let's just say in the lobby of a government building or in the library or so, they're going to say, well, how are you going to protect the floor when you're bringing your equipment in? And you very likely will be asked to do that. In this particular case, I think we purchased maybe 30 some sheets of this plywood, and at $60 a pop, you can imagine how much money that is. A fair amount of money. Now this was a last minute request, but the artists were awesome, and they said, you know, if that's what we got to do, that's what we got to do. So we went out and we kind of figured out how much plywood they could budget, and how much we could actually use or need for this carry deck. My point is, it's sitting on an island of plywood. What the artist, also needs to recognize is that with trying to keep within your budget, how do you move that plywood? Where do you get it from? This plywood doesn't come from just the local lumberyard, but it could be masonite, it could be cardboard. The fact remains is, we figured how much plywood we needed, and then we leapfrogged it. We offloaded it, stacked it, and then leapfrogged it from the site, from the entrance to the present site where the crane's sitting. And as the crane moved, we would leapfrog the plywood. Well, that took that took like a couple hours to get all of that set up. And time is money. The crane operator is charging you for that time too. So you kind of, you need to really pay attention to just setting up on the site as well.
All of these things build into the budget. So these are the things. This is why we kind of always encourage to really think about the budget in the front end, because these are those little unforeseen things that will chip away in the end. Next slide, please. So getting started. So we're going to break down those elements. We'll try to go through some. We've kind of been discussing a lot of these along the way. So, but what is an as-built? So an as-built is a document of record of the wall, ceiling, or ground to which your artwork will be attached. One must have the as-builts prior to engineering. Engineering is an important step that cannot be undervalued. Artwork in a public setting must be able to withstand the unique exposure of the job site, the install site, the public interaction, and the geographical conditions. And install job site conditions and restrictions at the time of install will drastically influence your install budget. And an install can quickly become complex if your project is on a construction site or in the public. Next slide. So an as-built, we can't, as-builts are super critical. So any wall, ceiling, or ground level installation will require you to understand the structural aspects of what and how you attach your artwork. In general, an as-built is a document of record that identifies how a substrate is built. This is not the same as the architectural drawing. It's not the same as a shop drawing either. And during construction, changes can occur. Hence, an as-built drawing is required for engineering the anchoring method. Next slide. So here we show you two examples of what an as-built that we would accept in creating a budget for install. So on the right is the document of record for the visual on the left. However, on the left is the actual job site under construction, which shows how the wall is structured and where the anchor points will physically be. So you don't always have the opportunity to see how that wall is built, especially if we see a lot of public art where it's a remodel to an existing structure, and your artwork might not be on that remodel. It might be on the original structure where you can't physically go and see the wall. So that's where we have to rely on the document, and which is usually the case. We actually usually need that document.
So why is this as-built here? Why did Sound Transit have to produce an as-built? Basically, because when they poured the wall, they were off dimension, I believe, in depth and then in width on the left-hand side, enough that it changed all kinds of other things. I'm not sure if it was HVAC, but I know there was electrical stuff that all had to be relocated. In anticipation of relocating that, they would have to build this wall a little bit different than was originally designed. So that created the need for an as-built. You're not necessarily going to encounter as-built all the time. It's only when there's been a change to the original document of record for that construction. General contractor comes up and says, hey, the concrete is poured in the wrong spot. We need to move this column a little bit. This wall's got to be furred out. It's got to be built. It's his job to get that redesigned, do a drawing so that it can be performed. And then once it is built, an as-built is generated. So it's a document of record. We encounter them a whole lot. Art isn't necessarily always figured in when the building is originally built, or maybe the art hasn't necessarily been awarded. So sometimes these foundations where the art's mounted is changed, adapted, configured as needed. So then an as-built happens. So you know, if you get into much of it, you will encounter as-builts, that's for sure.
Next slide. Engineering. So almost all public artwork will call for engineering. Engineering includes the structural integrity of your artwork and the anchoring method to the site. Engineering will answer all of the questions for installation. What kind of anchor will be needed? Will it withstand public exposure and abuse? Is this a high wind seismic flood zone? How much concrete is needed and what does that look like? Do I have enough connection points designed into the art? So engineering before fabrication is a smart way to go. And it's a dance. There's a dance to bring all of those together. Next slide. So the most effective engineering is designed by both the installer and the engineer. This is the most effective way to ensure that the engineering is valid and practical for your art, tools, and access. So this is one where,
yeah, so this is we're installing a large canoe over at the University of Washington. And it was on a curved stairwell, flat wall, but there was a curving stairwell. So we had to have we were going to install it from a scaffold. We had the scaffold guy out there, and we could only get the scaffold just so close to the wall because we needed to drop this sculpture. This is a carved wooden canoe. It's kind of attenuated in size there. It's actually maybe 23 feet long, maybe 4.5 feet tall. We actually carved out of cedar. So we actually had to lift it up over the railing of the scaffolding and put it on and hang it on a wall. Denise and I went over, we met with the scaffold people, met with the UW, and came up with a game plan. I did my little cocktail napkin kind of drawing here to show the engineer what we saw, what we think we need for the install. We actually looked behind the wall. We were able to get behind the wall to see that it was double layers of drywall. Regardless, so this is a cocktail napkin drawing that ArtSite produced for the engineer for dialogue. On the right is his actual engineered drawing. After discussions, that's what he came up with. You can see they don't look at all the same, but they are almost exactly the same. The key is if you do require engineering, that drawing on the right, you'll say, well, that doesn't look like an engineered drawing. That's not very fancy. It's pretty simple. It is very simple, but it is an engineered drawing. What you get with an engineering is the main thing you want to walk out of that with an engineer is you want the calculations, and you want those calculations stamped. The drawing can kind of be sort of anything the engineer thinks he needs and the installer thinks they need. But what you get from the engineering, you get the drawings for sure, but you really want the calculations and the stamp. And then your liability is diminished considerably.
next slide. So here to wrap up the engineering process, it includes on the left is the as-built. In the center is the sketch that everybody reviewed, the installer and the engineer reviewed together. And then on the right is the final stamped engineering with all of the calculations and everything that as an installer, whether it's you or a professional, you're required to follow that engineering. Next, please. Even a concrete pad needs to be engineered. So once the engineering is completed, one moves forward to the unique conditions of the job site. Next slide. So the job site. So this is what we always say. One needs to walk the path. It literally means walking the path from where you can park your vehicle with the artwork to the job site. For us, any quote provided prior to walking the path is subject to walking the path. We might be able to give you a rough because you can't always see what the path is going to be like at the time of install, but in the end of the day, we need to walk that path. So some of the things that one looks for when you walk that path is, are there stairs? Is there an elevator? Will it work? Is there a loading dock? Is it dock height? Is this a construction site with other vendors? What equipment will be needed? Scaffold, ladders, a lift? What's the path to get it to the job site? Do you have a comprehensive installation plan that works with that site? What is the working footprint of your install plan, etc.?
Peter got me to thinking earlier when he was mentioning that he was thinking ahead about the assembly of his hammer on site. So he has these openings, these access holes, so that he could bolt everything together. And so what Peter was doing there is he actually walked the path of the assembly of his art. So walking the path isn't necessarily just walking the path. It's mentally going through all of the motions that take from fabrication to installation. And walking the path is like, well, if I'm going to pour a dinky little concrete pad myself, or I'm going to hang some stuff from some trees in a park, or if I'm going to put some kind of posts in the ground in the park, how am I going to get those posts from the lumberyard to my studio to the install? Am I going to drag them on the path? Am I going to have a little cart? So that's all part of walking the path. Really just walk the path mentally.
Next slide, please. So we kind of show you a couple of examples of job sites that, this is when everything hits go. So this is a Susan Zokola install that we did up in Whatcom Community College. This was, the artist hired us. We had minimal interaction with the on-site people, but at the end of the day, when we got there, it was a very much a punch list for that construction site. And so as installers, we had to work with the on-site people to make it work. Next slide. This is an install that we did this summer for the city of Seattle. So a job site is, this is an example of how public a job site can be. This install is an exciting part in a community, and you can expect spectators. Next slide. This is the crate that we showed earlier coming off the truck. So this is one that we did this past winter. This is an ideal job site. Aside from the challenge of getting the crate in, this was a very tidy, clean, quiet job site where we had a nice big footprint to work in. But this is an exception. Next, please. This is a project that we also did for the city of Seattle last year. This is an example of where an install is itself generally straightforward and pretty simple, but the job site is tricky. So we're butt up against a railroad, which is not very active, but it does have some activity. We're installing on a wall outside of a very complicated job site, but we didn't need to go into the job site at all. But the people the general contractor that owns that job site is responsible for everybody who's working there, including our component. So we're on the outside, we're not on the inside at all, but it's still subject to all of the rules and regulations of any vendor working on that job site. Next slide. So to kind of wrap it up a little bit, we ask you to question, are you qualified to do your own install? And when and why would one hire a professional? Next, please. So so the questions, are you truly qualified to do your own install? Are you interested and do you have the time to manage the requirements of the install? Do you have the ability to recognize and access the equipment required for the job? Do you have the experience to recognize limitations and the liabilities of the install? Do you carry the right insurance? And are you willing to be a licensed general contractor? Hopefully after this presentation, you'll be able to answer, or you'll be able to look at each install a little bit differently and maybe nudge up to being qualified to do some of your own.
Denise went through these points real quickly, but they're really important ones. I mean, if I would suggest that anybody thinking about doing their own install get anything out of this, I think this slide would be one that you really need to sit down and look at and think about, because each one of those bullets, there's just so many other things that are in behind that you're going to see on any install in the public realm. So I would pay attention to each one of those bullets and really decide if you have the mental and financial abilities to bring those on to yourself.
Next slide. So why hire a professional art installer? The bottom line is because we actually take on all of that. And a trained and certified art installer brings a depth of hands-on and problem-solving experience to your project. In addition to the technical aspects, a professional installer is going to own all of the equipment, the tools, and have those certifications required. And often the person who owns that job site will expect to dialogue with someone who is qualified to answer their questions. Next slide. So a general contractor will develop a relationship with that, professional installer will develop a relationship with the general contractor. They'll understand the chain of command on a job site, which is a simple statement for a complex sequence of ownership on any particular job site. They'll understand the parameters of the job site. They'll develop comprehensive risk analysis, inclusive of a safety plan. They'll negotiate and coordinate the arrival of the equipment and the art. And they will respond to any technical questions related to the install. Next slide. Additionally, it's incumbent for the general contractor to recognize the artist's intent at all times, including on site. So we come back to this larger project where ArtSite was hired by the art team, and we were able to, with this pair, Studio 5050, we were able to work together with them on the job site. So they hired us because they knew we would respond to all of those general contractor requirements, but they also hired us because they knew that as a team we would work with their team, with them.
In this case, the artists, excuse me, in this case, the artists were the general contractors, and we were hired by them for our expertise in rigging and assembly of this sculpture. What was great about it is that these guys, the collaboration part came in the fact that we were working for them, but we really respected their movement of their objects within that site. They were super sensitive to these items being scratched, dented, and bumped, and so they hired us as art handlers with technical experience to do that. They could have hired a rigging crew to do it, but they didn't feel like the rigging crew would give the art objects as much care as we did. So,
next slide. A general contractor will secure permits, traffic control, and equipment delivery. This is a job site that looks like we threw a couple of cones out on the street, but this is Bellevue Way. And getting to that point right there was quite complicated. Next slide. This one we're just going to kind of cruise by, but we put this in here because transportation of the artwork to or from in this case, this is a deinstall, but transportation alone can be quite tricky as well. This was a oversized sculpture that had to move in the middle of the night with multiple permits were involved. Next slide. So some collaborations can be very rewarding, but it's important to allow the general contractor to determine if on-site collaboration maintains safety protocols and that all have the right experience. The liability ultimately falls on the general contractor. Next slide. So whether you go it on your own or you hire a professional, the basics are the same. Determine your install budget early. Get your as-built from the client. Don't skip on the engineer. Do it early and ideally before fabrication. And know the conditions of your job site at the time of install. You want to walk that path. Next slide. So that wraps up our presentation. And I know it went a little long, but there's a lot that goes into install.
Thank you, Denise and Roger. That was very comprehensive and touching on a lot of details from installation, even to getting to that point when even thinking about it from final design, from engineering, all of it. From here, I'd like to jump in and start with the Q&A that we've got that have been coming in. Maya and I will kind of be fielding those to go to Denise or Peter. If you have additional questions, feel free to write them into the Q&A now and we'll get started.
Great, and I'll kick off. Peter, there were quite a few questions regarding vendors and specifically desiring the name of the powder coater that you used in your example project. Would love for you to share a little bit about that and maybe how you go about even selecting vendors for your projects.
Sure. The powder coater that I used on that project and many other projects is Rmc Powder Coating. They're down in South Park, and I've been, like I said, I've been working with them for years, and they actually started out in a tiny little garage where they were powder coating just little tiny component parts for a variety of manufacturers, and they've now grown into this huge company. They've moved a couple of times and created huge powder coating ovens, and it's a family-owned business. Very small team of people, but really skilled. So I've used other powder coaters. I use these guys. I have used these guys primarily on these big projects, and this wood grain powder coating that we were talking about is a very unique thing that unfortunately they're not doing anymore. They did it only for a few years. Unfortunately, they've discovered that it just wasn't profitable enough. It's too time consuming and required too much hands-on work on their part. And so they just couldn't sustain it. So it's unfortunate because once I started using it, I kept designing other things to continue using it. And now I'm actually working on a project right now that I want to have some wood grain on. And so I'm struggling a little bit to find somebody to do it. Those guys are still working with me on trying to find a vendor that can do it, but it's not going to be the same. Yeah, and the other part of that question I think was about how I go about finding vendors. That's it. It depends on what I'm looking for, and I try to find somebody that can do the kinds of things that I want, that is flexible and can fit me into their schedule. And so they're oftentimes very small shops with very small number of employees. And I develop relationships with these people. There's a machine shop that I've been working with for decades now that, you know, if I need component parts machined, it's not worth my time to make them myself. I can draw them up and even have my CAD guy create really accurate, precise model drawings. And then I have these parts machined. So machine shops, powder coaters, water jet cutters. I've been working with a couple of different water jet cutters on many projects. But one of the things that's frustrating about it is that people retire, people die, and you have to find new ones, and that's a real struggle. And this has happened in particular with engineering. I had a structural engineer that I worked with for 20 years, and he died, unfortunately. And I've never found someone that I have the same kind of relationship that I did with him. I've worked with plenty of other engineers, but there are certain times when you develop a relationship that just makes the job go so much easier, and you tend to go back and work with the same people again and again because you get to know each other and you know each other's habits and idiosyncrasies and what makes the relationship work.
Great, thank you. That actually kicks off the whole next suite of questions really well. Is a lot of questions about structural engineering. Thank you, Roger and Denise, for kind of like stating the importance of an engineer. The questions include like, are there engineers that just specialize in public art, or would any engineer do? Is there any sort of cost guidelines of a percentage of project that artists should plan for working with an engineer? How to find? Are there any other considerations when trying to find someone to work with? And maybe Denise and Roger, if you want to start with that question of how to find someone.
Yeah, well, Denise and I have been in art handling business for probably 30 years. And so we have gone through a whole bunch of different engineers, and we have found maybe a half a dozen, certainly 3 or 4 that are art-centric. And so we gravitate to them almost all the time. It's odd having a piece of art engineered, because the average structural engineer would much rather engineer a concrete slab or a wall or a building than art. It's always historically, it's always, art's always the last damn thing that people pay attention to. And it's always seems to be maybe kind of too much work to get involved with art. And so you do have to call out a lot of that kind of thought and find art-centric engineers. Long story short, we do have some, one we've worked with for over 20 years, and he's absolutely awesome. And he appreciates art immensely, and he's very efficient and cost effective. So how that happens, though, is that you have to start somewhere and work with them. And like this drawing that's on the, I guess that's on the screen now. He's willing to take my little sketch and turn it into that. That little simple sketch is several hours worth of work for him, that's for sure. And he actually did a site visit as well. But it's important to have that and that dialogue with somebody that's going to be stamping that. And so basically you kind of sort of over the years interview this engineer is what you end up doing. And you go through or engineers, and we have them, we share them. We would, but it is hard. I guarantee you will not call up a structural engineer corporation and get them to do your art. They just won't do it. But they're there.
If I can jump in too, I would also add that like for us here at the city of Seattle, we're not allowed to give referrals to contractors as part of ethics rules here. But often what we try to do is we'll encourage our artists, if they're working on a project or looking for an engineer, to get in touch with one of the with the public artists that we've worked with, like Peter, and see if he has any recommendations. So we'll connect artists with other artists to sort of see if they can sort of share information. But there are a few engineers out there who do enjoy working with art projects. But yeah, they're kind of best if you kind of check in with other artists.
Great, thank you. Another kind of question about budgeting, install budget. Denise and Roger, would you mind sharing some of the kind of broad strokes approximation for some of the projects that you shared as your examples of what the install budget was? There was a specific question specific to the Gateway and Hing Park.
I don't remember exactly how much the Hing Hay one was, but it wasn't that much. But it was in the 50,000 range-ish. That transportation was a big chunk. And it took, was it 2 weeks? It took a
Conversation pads.
It was about, yeah, it was almost 2 weeks on site. So that obviously adds up. The crane that you saw came in for only 1 day just to do that one piece. And the rest of the time we had a big forklift there. You know, that right there is probably 8,000 to 10,000 for just those pieces of equipment. So that was about that budget. But then you can look at, like, say, Melvin's piece along the sidewalk. That took, I think, 2 or 3 days. Yeah, exactly, that one. And that was probably 3,000 or less. But we have no equipment in there. You know, we didn't have to close anything off. So it's a big range. But the important takeaway on budgeting is that is to do the homework up front and not take, you know, you get a $60,000 or $10,000 contract. What you don't want to do is say, oh, install is going to be about 10% of that. So I'll just put about 10,000 aside and I'll address it later, because that's where we see artists get into real trouble. And at the end of the day, you might not get more money. So you may end up not making any money on the job. And so that's kind of our important thing. And if you don't have the answers to all of the things that we highlighted, you know, that form an estimate, what we do is we do a rough order of magnitude that basically says, well, based on what's provided, you're looking at X dollars. And then here's a first phase that will help, that will hire us to talk to all the relevant parties, the engineer, the GC, the artist. You know, it'll allow us to do all of that brain work that may change that install budget. So it's kind of, yeah, I don't know which, anyway, it can be a very big range. The Corvallis one was in the 20 to 30,000. But, you know, at the end of the day with that one, they kind of got a pretty good deal because we were out of town for almost a week doing that.
When you're approaching your client, just what Denise said, rough order of magnitude, it's just a trade term, construction term, ROM. Look it up, you can Google it. But when you approach your client, the best thing you can do is to tell them, I'm going to give you a ROM. It's the same as an estimate, except that it's just a rough order of magnitude. I'm going to give you a ROM with some assumptions. And when you walk your path, whether it's making your art or fabricating your art or installing your art, when you walk your path, always write down your assumptions and always write down your questions, and on, in a little book, on a piece of paper, whatever it takes, and think about those as you progress through there, how that helps you develop your ROM, or how your ROM helps you develop your assumptions. But those two work together really quite well when you get them on a piece of paper. So I guess what I'm trying to say is your assumptions have to be noted to your client so that they understand what you have included, what you have thought about. And the client may say, well, wait, did you realize that this post is already there, or that post is falling over, you can't use that? So let them know what you're thinking about. You know, write that stuff down and present it as an assumption. It's a liability kind of thing for yourself.
Great, thank you. A question for Peter. As you're developing an artwork and a concept in your finished surface, are there methods or considerations that you take into account for mitigating vandalism, graffiti, stickers, etc., after it's installed and in place?
Yeah, that's a good question. Anytime you do work in the public realm, you have to anticipate that it's going to take some kind of abuse. And as I said before, it might not be malicious, it might just be general wear and tear, but you have to design for that. And what I try to do is consider the finishes and the materials that I use to be as durable and low maintenance as possible. There's a huge debate in the art fabrication world about whether or not you should use powder coating or paint. And there are two different schools of thought on that. And my preference is to use powder coating. I find that it's much more durable than any liquid paint. It's also much more environmentally friendly in its application because it doesn't require any solvents. It's a dry powder that's baked in an oven to create this finish. So it doesn't require it doesn't create as many environmental issues. So that's another reason why I use it. But again, if you're looking at that image of the hammer and nails, the components that are intended to be most interacted with are the benches. And so those are stainless steel with a brushed finish and no coating at all. So there's no coating that can be damaged, and the material itself is impervious to solvents and paint. You could remove paint from it using solvents. On the powder coating itself, I do also have them apply a clear coat over the top of any finished color coat, and that provides some extra UV protection to slow the fading of the colors, but it also creates a surface that will prevent paint or markers from getting into the color coat. So with very great care, it's possible to remove most of those vandal type markings on the finish.
Great. Jason, there's a request to put up the last slide with the summary again. I think that refers to Denise and Roger's. I think we can go to. And I see one more question for Peter of just regarding your building of a model and like kind of wanting to know the materials that you use for building a model and any sort of process that you put into doing that, the rationale of the process.
Okay. The models are usually made out of metal, just because that's the material and the process that I'm most comfortable with. But in every case, there are some variations on that. Sometimes they're made of wood, painted, often metal. Recently, I've been able to, because the CAD modeling is getting so sophisticated. The last couple of projects that I've done, I've actually had somebody take those CAD models and 3D print them. So there's a 3D printed plastic model of a couple of these more recent ones, which are pretty amazing and makes it very easy for me. They don't look as slick as the actual fabricated ones. Anything that's 3D printed, it has a certain signature look with the striations, which is, it is what it is. But the 3D printed plastic models are nowhere near as tough either, so you have to handle them much more carefully. But it's a pretty neat way to go. But most of them are fabricated out of metal and just working on a very small scale. And it's interesting too, because I don't really do that much studio work per se anymore, and haven't for 35 years really, because I've focused my attention and my energy on these large scale public projects. So the models are also a way for me to do work in the studio on a smaller scale. And ultimately, once a piece is installed, there are only two things I have as a record of it, and that is the model and the photographic documentation of it.
Great, thank you. I think we have time for one more question, and I'll pose this maybe first to Denise and Roger of like, how do you work with architects, landscape architects, both for artists and fabricators?
Well, They are generally part of the kind of what I would call like the secondary stakeholders. So the way we literally work with them is, you know, often there'll be like a massive group email, and that has everybody in it. And then we would maybe take that. They're not really related to the, you know, putting nuts and bolts into a wall or ceiling or a ground, but they're in charge, they're responsible for the property or the making of the art or that sort of thing. So you know, that's kind of a hard question to really answer. Architects are often involved, but at the end of the day, they're going to be secondary to the engineer. The fabricator, we'll get involved with the fabricator if we look at the engineering and the art. This is a situation that we're in right now. If we look at the artwork sketch and we're talking with an engineer, you know, we'll get involved with the fabricator if we want them to alter, like, say, attachment points or add them, but it's questionable to the aesthetic. Roger might have some more input on that.
I think real quick, I'll just try to get, there's, for us as our main focus is installing art, there's a really recognizable difference between dialoguing with an architect, be it a building architect or a landscape architect, than it is an engineer, than it is a fabricator. So the distinction between for us, architects, whether landscape or residential or commercial, they think that they own that building for life. You know, they designed it, and it's just kind of a little bit of trade humor among the construction business. Architects think they own everything that they design for life, and that's good for them that they do, because that means that they're really genuinely involved with it. And so anytime you go in and mess with their walls or their concrete or something, you get their attention really quick. So to answer the question, how you dialogue with these kinds of people is, I think, for you to learn as much as you can about the materials that you're going to be using, for your art, the materials you're going to be impacting for the installation of your art. Learn your terms, learn the difference between hardscape and landscape, learn maybe a little bit about concrete, but learn some terms so that you can effectively dialogue with these people, so they just won't dismiss you when you first approach them. Like I say, the architect side of the industry think that they own these objects that they design, and for intents and purposes, they're not going to let you interfere with them unless they trust you. And so my best guess to answer that question would be to learn your terminologies, learn how to present yourself to them. They watch your body language and see how comfortable you are with the topic of discussion. They definitely do that. Architects more so than engineers. Engineers are a little bit nerdy, and architects are a little bit more arty. And so, you know, architects go to the museums, engineers go to watch a bridge built. You know, so there's a different aesthetic between those two. So you'll get it once you get involved, but that's, I think, the best way to do it. And there's several really good books on that whole thing too that I could recommend you read. They're awesome. Anyway.
Peter, is there anything you'd like to add to that?
Yeah, well, I think one of the comments that Roger made that I think is really key is to be able to dialogue with those people, meaning learn the vocabulary that they speak and learn how to read blueprints, for example, so that you know what you're talking about when you sit down with them. That's pretty important. And one way to do that is to just gain practical real world experience in the construction industry, where you understand how things go together, and you understand who the people are that are involved in the project and what their roles are.
Oh, I'll just add really quick to, Peter, did I interrupt you?
No, I'm good.
We're horsing around here with our mute and unmute. One thing I want to add with Peter, or that Peter said, is like learn to read blueprints. They're blueprints. It takes years to learn how to read a blueprint pretty effectively, but you can get the gist of it. So along with that, if you are willing to learn to read blueprints, a very important thing to learn to read, and even with your engineering, is look at the specifications that the engineer will put on your engineering, or the notes that an architect will put on the blueprints. There's oftentimes very important details specified for that little particular area of that big piece of paper that you're looking at that you'll need to pay attention to. So it's not just looking at lines and dots and shading and stuff like that on blueprints. Those specifications, which are written out, are really the key to it. We see so many artists not have been privy to the specifications. It's like, oh wait, well this calls for this, you can't use that, that's the wrong hardware, or you got to get an inspection for this, you got to get this certified. So it's not just looking at lines, it's reading the words too.
Thank you, Roger, Denise, and Peter. I think that concludes our questions and answers portion for today. Again, big thank you to all of our presenters and our staff that helped coordinate today. We will be, this meeting's been recorded. We're going to take some time next week to upload it to our YouTube channel on our arts page.